Hey Brent, saw your message on the peer group and I downloaded your code, took a look at that, watched your video, and I put together a program to help you out. Doesn't do everything, but I think it's a good structure to help you out and you can fill in some of the pieces to it. So really taking your requirement, I really broke this problem down into different pieces because I really think it simplifies a program when you really think of that program in the terms of different actions that are going to happen, different events that are going to fire to trigger those actions. In this particular case, we need to have states because really what you're laying out sounds like a state machine. So depending on what state the machine is, when a certain event happens, you want a different action possibly to happen. And walking through that, here's what I came up with, is what I've heard from your requirements. And that is the different actions as laid out here. So we want to be able to lock and unlock the door, which that's going to be moving your servo position. I heard some of your stretch goals, but I want to throw them in here. So you want to be able to turn on and off a yellow LED, a green LED, a red LED, be able to stop and start a buzzer, as well as we need to start a timer. And in some of the events that I see within this is, obvious event is when the program starts, because we need to know that, which that event then is going to lead to the event of initialization. So this is when you described of once you first put the marshmallow on, you want to be able to set everything up, close the door, have the servo lock it. Then we're going to have events of the actual act of placing the marshmallow on top of the machine or picking the marshmallow up off the machine. And some of the states that I came up with through this is, also we have the state of being start. So when you first power on the Arduino, then we're going to have when you place the marshmallow down. So that's going to be the state of the act of putting the marshmallow onto the sensor. There's a state of picking the marshmallow up too soon before the timer has completed. So that's in itself is a state. So the when state is the timer actually completes and the marshmallow is still on the sensor. And then I had a last state here of just game over, which that is a state of when you've gone through the when state and now we've unlocked the door and revealed the other marshmallows. So that kind of marks it as being game over. So let's walk through some of the source code, and then I'll do a run through a demo, because as part of writing out the source code, I put a lot of serial print lines in here so that you can use the serial monitor to actually see what is happening within the program. I set up a simple circuit where I have the photoresistor, so I can put my finger over on it to simulate the physical placing the marshmallow on or removing the marshmallow. I did not hook up the servo or actually hook up any LEDs for my circuit. Like I said, I've put places in the code where you can control all that by controlling all the digital and analog pins, but I'm leaving that for you to add into it. I'm just leaving the placeholders in here so you know where you'd actually apply that code to cause those actions to happen. Then I just annotated through, so using the serial monitor, you can see anytime an event happens, how the state of the machine changes, as well as what actions we perform on that event and based off what the current state of the machine is. So let's run through some code. So I'll upload this file. I'll provide a link down below to the source file so that you can have the source code as well. But just walking through this source code, here at the top, I just went ahead and created some comments to lay out the different states as I see it, the events and the actions that are defined in here. Created a few more variables here at the top. Probably some of the ones of interest. So this LDR threshold is the variable that sets the value that we read back from the LDR. So if the value is less than this, the program is assuming that the marshmallow is over the sensor. If it's equal or greater than this, it's assuming the marshmallow has been picked up. Of course, you'll have to change this value to match what works for your sensor and your environment, because I assume 150 in my light in my office is going to be different than what you have in your environment. LD covered is just a state variable I'm keeping track of, so that way I can easily track whether the state of the marshmallow being picked up or placed changes over time. Some variables around the timer. These two variables are what's left over from your previous code. They're not currently used. I'm going to delete those out. So then I'm using an enum. So this is just a different data type in C++ that allows us to use names in place of numbers. This just makes the code much easier to read. As you see, as I walk through the code and as I'm setting the current state, which we're using the current machine state variable to know what the current state of the machine is, I'm going to be setting it to these names as opposed to numbers, which just makes the code a lot more easier to read. We still have the setup function, which we're going to set up serial so that we can have some outputs. Servo attach is still in here, but I'm currently not using it since I don't have a servo hooked up to mine. Said the current machine state. Here's where we're going to start off by saying I want the state is going to start, or the current state of the machine will be start whenever you power on the Arduino. I'm going to output some info here so we can easily see as the states change within the program. And then the very first action, as you mentioned, is you wanted a yellow LED to be turned on while the machine is waiting for you to place the marshmallow on and lock the door. So when we start up, first thing we want to do is turn on that yellow LED. I think this is a good point two is to make this much more readable, I create a lot more functions. So as we go through the program, you're going to see that there's 3 different types of functions that I've laid out. There's a set of functions that are the actions. So here's our first example of that is turn on yellow LED. So I have wrote functions to perform the actions. So there's functions for, we'll scroll down to those. So here under the comment of action, here's all my action functions. There's a function to lock the door, unlock the door, turn on yellow LED, turn off yellow LED, turn on green LED, turn off green LED, turn on red LED, turn off red LED, start the buzzer, stop the buzzer, and start the timer. So these are all of the actions that can happen with this program, and I gave each one its own function, which makes it much easier to read and follow the logic of the program. Within Arduino right now, I just simply have these collapsed, but if we were to expand these functions, you'll see inside here. So as an example, on the lock door, unlock door, I'm just simply printing out that action. But again, leaving it to you to actually put the code in here that is going to talk to your servo and move the position of the servo. Same thing on these LED functions. I'm printing out that the action was called, but I'm leaving it to you to do the digital pin right to make it high or low to turn on or off these LEDs. And then the second type of functions we have in here are what I'm calling events. So this is where we have the function for the event when the marshmallow is placed onto the sensor, event for when the marshmallow is removed from the sensor, that initialization, which happens at the beginning of when you power on the Arduino and put the marshmallow on for the first time, and timer complete. So after that 1 minute has passed on the timer, I actually want to fire an event or have this event happen, which is going to be called timer complete, which we can see then inside these events is where we're going to change our current state as well as perform some sort of action. And then the third type of functions is what I'm referring to, of course, is just the general glue that holds it all together. So you got your setup function here at the top, as well as down here at the bottom, we've got 3 other functions, which one is our loop function, which obviously we need to have in place. And then we have a check marshmallow, which this function is just checking the status, or it's reading the value from our photo sensor, and based off it, it is going to either fire the event that marshmallow was placed, or it's going to fire the event that the marshmallow was removed. And we have our check timer, which this is our function that is simply every time the loop is getting called, as long as the machine's in the right state, which for us means that the marshmallow is in place and we've already been initialized, it's calling through here and just checking the current milliseconds minus the milliseconds of when we start the timer, see if our time has passed. If so, then it's going to fire the event that our timer is complete. Okay, so let's walk through the flow of the program. So at the very beginning, as I said, in setup, first thing we want to do is we're going to set our current machine state to start, and then we're going to turn on our yellow LED. And then from there, the next thing that happens is it goes into our loop. And what our loop is going to do every time through is it's going to call this check marshmallow. Take a look in check marshmallow. This is going to read the current value of the photoresistor. And if the photoresistor is less than our threshold, and we know that the photoresistor wasn't covered previously, then we're going to say, oh, the photoresistor has now been covered because we've placed the marshmallow on top of it, and now I want to fire the event of marshmallow placed. Else, we're going to say if the photoresistor value is greater than or equal to our threshold and the LD cover has been covered, then I want to set the cover to false to maintain that state, and then I want to fire the event that the marshmallow is removed. But again, going through the very beginning of the program, first thing that's going to happen is you're going to turn the machine on. There's going to be no marshmallow on it. So when we come into here, we're going to place our marshmallow in place. And that's going to cause the marshmallow placed event to be fired. So let's go take a look at that event, which is up here, which is marshmallow placed. So then marshmallow placed, besides doing some debug outputs here, this is where we start using our state machine. And the first thing we want to do is saying, which state are we currently in? Are we in the start state, or are we in the marshmallow picked up too soon state? Because when a marshmallow gets picked up, we actually want two things to happen. If it's picked up when, So when a marshmallow is placed onto the machine, you can think of there's two different things we care about. Is it being placed on the machine for the first time, which is what this state of current state equals start is, or is it being placed back down onto the machine after they picked it up and they picked it up too soon, which is what this state is of the marshmallow picked up too soon. If it's for the first time, we call it initialization. Within initialization, we're going to walk through here and say, let's lock the door, which is going to set your servo. Let's start our timer, and let's turn off that yellow LED because we're now past our initialization phase. And in addition to that, we're going to transition our machine state to the marshmallow in place state now. And now we've done that, we'll fall back out of this. We go back down to our loop. And now in our loop, as we loop back around, now we're checking what's our current state. We know our state now is marshmallow is in place. So for our marshmallow in place, we're calling check timer. Calling on check timer is where we're just looking to see the purpose here is to see has enough time passed for us to fire our timer complete event. If it has, we fire the event. If it's not, we just come back out. We come back to our loop, we're checking our marshmallow. So now, when we go into check marshmallow, if we know that the LDR is covered, so we should never go back into this place one until we've gone into marshmallow removed. So if the sensor indicates that the marshmallow's been removed, now we call marshmallow removed event. When we fire that event, we look in here, here's another function where based off of the current state of the machine, it will do different things. If we come in here and our current machine state is when, which is not, our current state is that the marshmallow is in place, which means this if when is going to be false. We will not execute that code. Next we go in here, is current state not equal to game over? Well, marshmallow in place does not equal game over, so yes, this is true. So we go into this one, and what happens is says, oops, too soon, meaning we've picked our marshmallow up before our timer has been completed. So we want to set our current machine state to marshmallow picked up too soon. We're going to turn on the red LED, and we're going to start our buzzer. And those will keep going. So now we're back down to our loop. As we go through our loop, it's going to keep checking our marshmallow status. So check marshmallow status is just going to look until when they place the marshmallow back down. If they place the marshmallow back down, keep in mind right now that the state we're in is marshmallow picked up too soon. So now when we go back to marshmallow placed, is our current state when? No. Oh, that's removed. We go back up to marshmallow placed. Is our current state equal start? No. Is our current state marshmallow picked up too soon? Yes. So here we're going to say let's put the current state back to marshmallow in place. Let's turn off the red LED. Let's stop the buzzer. And now the marshmallow is back in a good spot. And this will keep going. So if we go back to our loop, and if we keep going through our loop and they never pick up the marshmallow, then eventually what's going to happen is our check timer is going to finally count up enough seconds, and when it does, it's going to fire timer complete event. So if we go look at our timer complete event, on timer complete event, it's going to set our current machine state to when, and on that, it's going to turn on our green LED. Now here's where I might misinterpret your requirements, but I have it where when the timer expires and the marshmallow is still sitting on the machine, all it does is turn the LED green. They have to now pick the marshmallow up, which when they pick the marshmallow up, that is going to again fire the marshmallow removed. When we come in here, our current machine state now equals when, which now means, okay, let's set the current game state to game over. And then we're going to unlock the door, and that opens the door for them. Now obviously you can change that logic and say the door unlocks at the same time that the timer events, at the same time that the timer completes, which is what I put a comment here for. So you could just open the door at this point if that's what you want, without them having to pick up the marshmallow. Okay, now let's actually go through a demo of that. So I'll hit reset on my Arduino, and here we go. So as we look through the code on the side here, we can see event program started and it's set machine state. So here we go. Our program started, our machine state is set to start. And then here's where I turned on the LED. So I see action turn on yellow LED. And so the machine is sent there waiting for me to place the marshmallow on top, which I'm going to simulate by putting my finger over the photoresistor. I do that. Now we see the event fired of marshmallow placed. It called initialization since this is the first time, which sets the machine state to marshmallow in place, which performs the action of lock the door, start the timer, and then it turned the yellow LED off because now we're past initialization. And now you see our timer's counting down. If I leave my finger on, I think I have this currently set to 30 seconds. So this variable here, time limit 30. So when it hits 30 seconds, you can see the event timer complete fired. The machine state changed to when, and it turned on my green LED. And now when I remove my finger, that's me picking up the marshmallow. So I got marshmallow removed, machine state changed to game over, and it unlocked the door for me. So there's the happy path. That's everything went through clean expected. Also notice right now, if I happen to put my finger back and off the LED, I still are firing the events that the marshmallow is placed and removed, but notice how the state of the machine is not changing at all because the game over, what did I say it was? That's because the game over state is the last state, and so perform those two actions. If we look again in here, marshmallow placed, you'll see that there is no logic in here for it to execute anything if current machine state equals game over. And same here within the marshmallow removed. If current game state equals game over, it's not going to do this if statement or this if statement, so it doesn't perform any action. So to reset the machine, we reset the Arduino. I'll clear my output. Reset. So now we're back at reset state. If I am to place my finger over the photoresistor, we can see it initialized. Now this time, if I pick up the marshmallow too soon, you see we fired the marshmallow removed event, which changed our state, machine state to marshmallow picked up too soon, which turned on the red LED and started the buzzer. And notice our timer, even though it's not printing out anymore, the time still actually is ticking away. And this is one thing you might need to consider in your requirements is at this point, when I put my marshmallow back down, the simplest solution here is simply just restart the timer all over again. If you actually want to have the timer start again but pick back up at 8 seconds, then that's going to take a little bit more complexity in the code, how to keep track of the time the marshmallow was off and subtract that from the time of the timer was running. Because for example, when I put my finger back on, you'll see, okay, my finger was off for 43 seconds because you can see the timer now is at 50 seconds. So the timer was still actually counting with the marshmallow off, you just didn't see it. Which is why then it immediately went to fire the timer complete event, and then machine state went to when, which turned on the green LED, and I remove the marshmallow, game over, and then it unlocks the door. Let's do an example where I don't keep my finger off for so long. So we initialize everything, it's counting. I take my finger off, marshmallow removed, turns on the buzzer. I can put my finger back on. So now you can see that the machine state changed to Marshmallow back in place. The red LED turned off, buzzer turned off. They turned on when I move it. They turn off when I put it back. So hope this helps and that I did a decent enough job explaining how this works. If not, feel free to send me another message because I don't mind helping out. Thanks. Good luck on getting this all working with your project. Also, good luck with hopefully you find this too is this project isn't over for you just today or tomorrow, but you can see how you can just keep building on this and adding more to it. And hopefully the code is now in a very intuitive layout for you, so you can easily see how you can actually add more actions and more events to this if you wanted to, or actually take this whole thing and apply it to a whole different machine that you build, but still use the same paradigm of using the states, the events, and the actions.